In triangle ABC, AC is 8 centimeters, BC is 10 centimeters, and ABC is 32 degrees. Find angle BAC. Now, in order to do this question, first of all, you need to draw a non-right angle triangle. We don't know if it's right angled or not, and then fill in the information. So it's going to label this side here A, this side B, and this side C, and I'm told that this angle here, angle BAC, is 32. Sorry, ABC is 32 degrees, and I'm told that BC is 10 centimeters, and I'm told that AC is 8 centimeters. Right, I'm going to use, in this case, I want to find this angle here, and I'm going to use what's known as the sine rule. I cannot use the cosine rule because the cosine rule is only used in two cases. If you have two sides and the angle in between them, sometimes called the included angle, and you want to find the third side, or you have three sides and you want to find an angle, which we don't have in this case. So using the sine rule, and before we do that, you should label the sides. So opposite A we goes small a, opposite B goes small b, and opposite angle C goes small c. We don't need one with C, so using the sine rule, and we have sine A over A is equal to sine B over B. If we're finding angles, it's better to put the sine A at the top and the length underneath. If you're finding a length, then it's better to do it the other way around. Putting in the information that we have that sine A over 10 is equal to sine 32 over 8. So let's just have a look. Sine A over 10, that's okay, is equal to sine of 32 over 8. That's okay. Therefore, sine A is going to be equal to 10. Bring that 10 up here. Sine 32 over 8. And therefore, if I want to find A in one go, I'm going to do sine to the minus 1 of 10 sine 32 over 8. Right, get this on my calculator. So here I have my calculator, so I set off in calculation mode. And at the moment, my calculator is in radian measure. Now you could change it into degrees, but it's not necessary. I'm going to show you a little trick here to use degrees in radians. So we want trig sine to the minus 1 of 10 times trig sine of 32. Now here's a little trick, it's 32 degrees, so go to the pi sign down here and select it, and then press that one. We get a little degree sign along with an arrow key, divided by 8. Okay, so that will work out sine to minus 1 of that, but unfortunately the answer here is in radian measure. Now the little trick is to do this. So go to catalogue, and when you go onto catalogue, it will be up here for the first time you use it. So just move it down to this one. It says DDD, which is this one. Click it, and then it will go answer DD. And what this does, it takes the answer in radians and changes it to degrees. So we're going to get the answer 41.4831. Okay, now there are two possible answers to this. Okay, because sine is positive in the first and the second quadrants. Okay, we've got a few more calculations to do, yeah? Because sine is positive in the first and second quadrants, we're going to do 41.5, or we have to check 180 minus 41.5. So what I've done here is done 180 minus 41. Now the only disadvantage when you're working in radian here, you cannot use the answer function, so you have to actually type this in. So remember that, and you get 138.517. The reason we do this is because sine is positive in the first two quadrants. So we've got two possible answers. Now, not always will we have two possible answers. So this one will definitely be possible. Now to check to see whether this one is possible, we take 138.5 and add it to the given angle, which is 32 degrees. Okay, which I did here on the calculator. Okay, and I check that and I get 170.5. Because it's less than 180 degrees, which is the maximum number of degrees it allowed in a triangle, then the second answer is possible. Now sometimes you'll do this and you'll go over 180 degrees, therefore there's only one possible answer. This is known as the ambiguous case for the sine rule. And in standard level maths you need to be aware of this when you're finding angles. So there are two possible answers in this question. So there are two possible triangles that can be drawn. One has A at 41.5 and the other has the A at 138.5.